So today I wanted to take a look at three different types of logic proofs here that you might see in discrete mathematics, and you might also see this in certain levels of geometry as well. So let's take a look at this. It says we're given these premises or givens here at the top, and we're trying to conclude not R. What I suggest we start with here is whenever you're given a single letter, to start with that single letter. So first let's make our statements and reasons column here. So we have statements and reasons. Okay. So number one. Again, if you have a single letter, I suggest starting with that. P. So one, this will be a given, or some people might write this as a premise. Two, we have not P and K. I'm going to start with that one because I could see I have a P here, so I'm going to do the next statement that also has a P. So that would also be a given in this case. Now three, you can actually rewrite this second statement as not P or not K. And that was from De Morgan's law. Okay, and that's on line 2 there. Now combining lines 1 and 3 here, if we have P is true, that means that not P has to be false, which means that not K would have to be true in this case if that's an OR statement. Because in order for an OR statement to be true, one of those has to be true. So if not P is false, then not K has to be true here. So if we have not K, the reason we got that is by disjunctive inference from lines 1 and 3. And now we're going to write down 5 here. We also have that other given that says R implies K. So in this case, that's a given. And then 6, from lines 4 and 5 here, well, if not K is true, that means K is false. And in order for this conditional statement to be true here, either both R and K would have had to been true, or just R would have had to be false. So if we know that R is false in this case, that means that not R must be true. And we call this here modus tollens. So this is by modus tollens, and that was from lines 4 and 5. And that was what we were trying to conclude here, so we would be done in this case. Alright, let's take a look at another example. So number 2 here. So let's have our statements and reasons. So 1, again, I'm going to start with the single letter here, which is R. Given, or premise, so you might say. 2, the next one that I see that has an R in it is this R implies Q. So 2, that was also given. So now if R is true, and that's true there, then in order for this statement to be true, then Q has to be true. And we call that modus ponens, and that's from lines 1 and 2. Some of you might actually see this written as the law of detachment. That's the same thing as modus ponens here. Modus ponens or law of detachment. 4, and now if we know Q is true, we also have that statement in our premises there which says S implies not Q. That was a given. And now if Q is true, that means that not Q is false. So again, in order for this conditional statement to be true, that means that our hypothesis here has to be false, which means that if S is false, not S would be true. And again, that's by modus tollens, and that would be from lines 3 and 4. And again, there's what we were trying to prove. So we'd be done in this case. Okay, let's take a look at one that's even harder than this. So number 3, so they give us all these givens here and they want us to conclude H. Okay. So again, we have our statements and our reasons in this case. Alright. So in this case here, again, I have a single letter B. So I'm going to start with B. And that was given. 2, once I have B here, well, I see this first statement has a B in it, but I need to state this first part here, which is B or D. And the reason I can do that is if this is true, then I already know B is true, so I can put or anything, and that's going to be a true statement, because only one of them has to be true. So this is just simply a disjunctive addition. I'm just adding on something else here to line 1. Alright. Then 3, now I can say that whole given there, B or D implies D or E. Well, that was given. So now, if B or D is true, then that's true, which means D or E has to be true. And that's that law of detachment, or modus ponens, from lines 2 and 3. Now, again, I can see that D or E in that second given there. But the first part of this says D or E or J. So D or E or J, I can now say that's true because I know D or E is true. This is the same thing we did before. Again, it's just that disjunctive addition. To line 4 there. Which I guess I should have put this up here, disjunctive addition to line 1. Okay, and now if I know that, now I can state the whole statement that D or V or J implies G or H. And that's going to be, again, just that law of detachment, or modus ponens, from lines 4 and 5 in this case. I'm sorry. I'm jumping ahead of myself here. That's just our given statement. Now we're going to say that G or H is true, and that's our modus ponens here. I'm sorry, and that was from lines 5 and 6. Jumped the gun a little bit. Okay, as you can see, if this whole statement's true, and this is true, then that has to be true. That's, again, that law of detachment. Okay, now if we have G or H is true, we could say G or H implies not D. That was a given to us right here. Okay. And then number 9 here, again, if G or H is true, and this part's true, which means this part has to be true. So not D is true. Again, law of detachment, or modus ponens. That's from lines 7 and 8. So now we have not D. 10 here. We have that last given, which is not D implies not G. So given. And now again, if not D is true, not D is true, then not G has to be true. Again, modus ponens from lines 9 and 10. And now if you take a look at line 7 here and line 11, if not G is true, then G has to be false. But we know G or H is already a true statement. So that means that H must be true in that case. So we can conclude H here. And that is just a disjunctive inference. And that was from lines 7 and 11. And that was what we were trying to conclude. So we have finished our proof here. I hope this helps. If you have more questions or if you would like to see a specific example, leave the problem in the comments below. Alright, I'll see you soon.